Hey everyone, and welcome! Today, we're diving deep into one of the most mind-bending technologies out there, generative AI. We're going to trace its incredible journey, all the way from being a kind of digital artist that can create amazing images, to becoming an intelligent, autonomous agent that can actually do things for us. So, let's get right into it. Just take a look at this. It's got depth, it's got nuance, it feels creative, right? But here's the big question. Could a machine, a bunch of code, have actually imagined this? That single question is really at the heart of everything we're talking about today. It kind of forces us to rethink what creativity and even intelligence really are.
All right, so first things first, let's peel back the curtain and look at the core mechanics. We're going to get into how an AI can generate text and code and images that, honestly, are often impossible to tell apart from things made by a person.
So, at its most basic level, generative AI is, well, exactly what it sounds like. It's a type of AI that doesn't just analyze or sort information, it actually creates brand new, original content. But here's the really important part. It does all this by learning the patterns, the styles, and the structures from just massive amounts of data it was trained on. And this brings up a really key distinction. See, for years, most of the AI out there was what we call discriminative. Its whole job was to classify things, to tell you if a picture is a cat or a dog. Generative AI is a whole different ballgame. Its job isn't to judge, it's to create a brand new, totally synthetic picture of a cat that has never, ever existed before.
This quote really nails it. The AI isn't just pulling ideas out of thin air. You can think of it as an incredibly sophisticated mimic. It studies a data set to learn the unwritten rules, like what makes a human face look like a face, or what makes a sentence sound natural, and then it uses that deep understanding to generate something completely new but totally believable.
So, how does this magic trick actually work? Well, it's not just one single technology. It's actually a whole family of different models, each with its own approach. Let's meet a few of the key players in this generative family tree. First up, we've got something called variational autoencoders, or VAEs for short. The best way to think about a VAE is like a skilled artist. It doesn't just copy a painting, it studies thousands of them to learn the absolute essence of a style, the brushstrokes, the colors, the whole vibe. Then, it squishes all of that information down into this compact mathematical code, and from that compressed essence, it can then paint entirely new, original works that perfectly match that style. Okay, next up is something really cool. Generative Adversarial Networks, or GANs. This is just a fascinating concept. Imagine a game between two AIs. One is a counterfeiter trying to make fake money, and the other is a detective trying to spot the fakes. The counterfeiter makes a fake, the detective says, nope, that's fake, so the counterfeiter has to get better. But then the detective has to get better to spot the new and improved fakes. This constant cat-and-mouse game forces both of them to become absolute experts, and the result is fakes that are just unbelievably realistic.
Now, VAEs and GANs were absolutely revolutionary, but the whole field was about to experience a massive earthquake. This brings us to what's called the transformer architecture, and believe me, this was the breakthrough that made all the huge, powerful models we see today possible.
You can literally see the acceleration on this timeline. We go from VAEs and GANs in the early 2010s, and then bam, 2017, a research paper comes out with the incredible title Attention is All You Need, and it completely changes the game. This paper introduced the transformer, and it is the foundation for pretty much every large language model, or LLM, that you've heard of.
So what was the transformer's secret sauce? It's a superpower called the self-attention mechanism. Now, in simple terms, just think about how you read a sentence. You just intuitively know which words connect to which other words to create meaning. Self-attention lets the AI do the same thing. It can look at an entire sentence at once and figure out which words are most important for understanding the context of every other word. This ability to see and weigh relationships is what made these models so incredibly powerful.
And this one breakthrough led to a whole family of famous models. You've got GPT, which is amazing at generating text. It's like a super-powered autocomplete that predicts the next word. Then you have BERT, which is designed to understand the context of text from all directions at once, which makes it perfect for things like search. And then there are models like T5, which are kind of like the Swiss Army knives of AI, super versatile tools for all sorts of text jobs like translation or summarization. Okay, so this incredible progress in understanding and generating language totally set the stage for the next big leap, AI agents.
This is the point where AI stops being just a chatbot you talk to and becomes an active assistant that can interact with software, use tools, and actually complete tasks for you. And it all starts with something super simple, just like this. A user tells a chatbot, "Hi, I want to book a flight." Now on the surface, this just looks like a normal conversation. But under the hood, something way more complex is happening. Because behind that simple chat is an AI agent. It's not just a language model anymore. It's an LLM that's been given the power to reason through a problem, create a step-by-step plan, and, this is the most important part, use external tools to get the job done. Think of these tools like apps on your phone. They're APIs that let the agent connect to outside services, like a flight booking website.
So here's what the agent is actually doing behind the scenes. First, it figures out the user's main goal. Then, it realizes it's missing some key info, so it asks follow-up questions. Once it has what it needs, it calls a tool, an API, to go search for flights. It brings those options back to the user, and once you make a choice, it calls a different tool to go and complete the booking. It's this whole multi-step autonomous process.
So, this incredible new power, it's a classic double-edged sword, right? The potential for good is just immense, but it comes with a bunch of very serious risks and challenges that we really have to face head-on.
I mean, the promise is absolutely staggering. We're seeing generative AI speed up drug discovery in healthcare. It's helping developers write code way faster. It's opening up new possibilities in robotics, customized education, and, of course, every kind of creative work you can imagine. It is touching almost every single industry. But that same incredible power that unlocks all this potential also creates some equally big challenges. We just can't talk about the good stuff without being honest about the perilous side, too.
One of the most fundamental problems is data bias. It's pretty simple. If the data an AI learns from is lopsided, with way more data from one group than another, then the AI's output is going to reflect and probably even amplify those existing biases. Garbage in, garbage out. And then there's data privacy. This number, it's just chilling. Researchers were able to spend only $200 on API calls to craft these sneaky prompts that tricked a major AI model into spitting out its private training data. I'm talking names, email addresses, phone numbers. It just goes to show how fragile these systems can be.
And the list of these hurdles is long. You've got the ability to create realistic deepfakes, which could pour gasoline on the fire of misinformation. We're facing massive legal battles over copyright for AI-generated work. And of course, there are very real fears about job displacement, not to mention the enormous energy cost of training these giant models.
And this all leads us to a final, more philosophical question, and this quote gets right to it. Are these models really creating anything, or are they just the world's most sophisticated parrots, brilliantly remixing all the patterns they've ever seen, but totally incapable of a truly original thought?
And really, that's the question I want to leave you with today. As we build these machines that can write poems and compose music and create art, it really forces us to look in the mirror. As AI learns how to create, what does that ultimately teach us about the nature of our own, uniquely human creativity?